Chapter 11, Area of a Triangle. Now, for the most part, many students wonder how exactly a whole chapter can be dedicated to the study of the area of a triangle. Trust me, triangles are perhaps the most important geometrical shapes we have. You will never hear the end of triangles. As simple as they may look, triangles carry very complex information. Previously, we saw that the area of a triangle is calculated as a half base times height. Two quick things before we get further on. 1. When we label the sides and vertices of a given triangle, we do not do it randomly. This triangle is named on the vertices A, B, and C. The way we label the vertices dictates the way we label the sides. Vertices are named using capital letters, but the sides are labeled using small letters. Side A is the one opposite to the vertex A, this one. Side B is the one opposite to vertex B, and C is this side opposite to vertex C. Secondly, when we use the formula a half base times height, how exactly do you tell which is the base and which is the height? For triangles like these ones, it is very easy to tell. But an obtuse triangle like this one, you see, you can choose any side to be the base, and that should then dictate where the height is. In general, h is the perpendicular distance from the base to the third vertex. In certain cases, the height is outside the triangle. For instance, if you chose QR to be the base, then the height is here. Notice that the base remains the length QR and does not include the extended part. If you chose PR to be the base, this is the height. If you chose PQ, then the height is this length. In fact, the correct name is perpendicular height. Now let's see another formula for calculating the area of a triangle. Now consider this triangle ABC, in which the length AC and BC and the angle C are known. In this triangle, line BD is perpendicular to AC. This is the perpendicular height of triangle ABC with base AC. The area of triangle ABC is given by a half B times H. But then, in triangle BCD, sine C is equal to H over H, where A is the length of BC. This means that H is equal to A sine C. Substituting H in the formula area is equal to a half base times height will give us area is equal to a half B into A sine C, or simply area is equal to a half AB sine C. The perpendicular height of a triangle, we've said, depends on the choice of the base. The base and the height must be perpendicular to each other. If we draw a perpendicular height from A and C, similar expressions of the area can be obtained. If we dropped it from C, then area is equal to a half BC sine A. On the other hand, if we dropped it from A, then area is equal to a half AC sine B. In general, area is equal to a half the length of two sides times the sine of the included angle. For example, calculate the area of an equilateral triangle of side 6 centimeters. Now, this is the triangle. Because it is equilateral, all angles are equal and are 60 degrees. And so we have a half times 6 times 6 times sine 60. Notice 60 degrees is the angle enclosed by the two sides measuring 6 centimeters each. So we have a half times 6 times 6 times 0.866. That gives us 15.588 centimeters squared. Now we can prove that using our usual formula of a half base times height. Here is the triangle. We drop a perpendicular from P which will bisect QR. And so QM is equal to MR and is equal to 3 centimeters, right? We find PM using Pythagoras theorem. So h squared is equal to 6 squared minus 3 squared. H squared is equal to 27 and h is equal to 5.196 centimeters. Area is equal to a half base times height, and that is a half times 6 times 5.196, and that gives us 15.588. Same answer. Another formula, the Heron's formula. Sometimes you could have all the 3 sides of a triangle but not a single angle. But you can still calculate and find the area of that triangle using the Heron's formula. For a triangle with sides A, B, and C, area is equal to the square root of S into S minus A times S minus B times S minus C, where S is half the perimeter of the triangle. That is, S is equal to a half A plus B plus C. Let us work the area of the equilateral triangle of side 6 centimeters and pretend we don't know the angles. And so S will be equal to a half into 6 plus 6 plus 6, and that gives us 9. So we have square root of 9 times 9 minus 6 times 9 minus 6 times 9 minus 6. That gives us 9 times 3 times 3 times 3, which gives us 243, square root of which is 15.588 centimeters squared.
One of the wonderful things about mathematics, I think, is that people are impressed. It's often seen as a very hard subject, and so if you've done math, it's often treated as an entrance requirement, as a credential to do lots of other things. And so one idea is that for example, some MBA programs, the only thing they require going into it is a good, solid math understanding. They can teach you all the business. They just can't teach you the math fast enough. And so I think that math, aside from obvious careers that require math, if you're going to go work in a department that does operations research or something like that, they'll want people with specific skills in mathematics. But math is often seen as a filter or as a screen for many, many other disciplines. And so I guess what I'm trying to say is you can think broad, because math actually is a solid preparation. It's a good credential to go into lots of different fields that people often don't consider at the beginning.